All right, after a little of a break, we are back into the game. So, welcome back to Code with Akya. Today, we'll be covering an interesting algorithm which is called as the Floyd Warshall algorithm, an efficient algorithm to find the shortest path between all pairs of vertices in the graph. So, if you ever need to evaluate every possible route in the network or transportation system, this algorithm is your go to. So, let's get started with it. So now let's understand what exactly is Floyd-Warshall algorithm anyways. So Floyd-Warshall algorithm is an all pairs shortest path algorithm which computes the shortest path between all pairs of nodes in a graph. It works with both positive and negative edge weights, making it versatile. However, it cannot handle negative weight cycles. So it can work with the edge weights, but it cannot handle those cycles in regards. So now let's understand certain steps, like how do we even perform this anyway? So how does it even work? So the first thing that you have to do is, so the first thing we do is initialize the distance matrix where the value at position I of j represents the distance from node I to j. So basically what we do is it's going to be a really dynamic programming which is going to be iteratively improve the shortest path between each pair of vertices, right? So the second step is for each node consider it as an intermediate point between every pair of I to j. So if passing through an immediate intermediate node gives you the shortest path, update the distance. That's it. And then after completing the process of all pairs, you have to give the shortest path between every pair of vertices. That's what the process simply is. Now let's take a quick look at the pseudocode. So what exactly the pseudocode says. So pseudocode is going to be our simple look at just or check out program where we'll just see our entire program in, or let's just say our entire practical into theoretical form. So you can just look at it or pause the video and can look how we are going to perform this entire program. And let's just go into practicals. So basically we are onto our computer screen now. So first of all, we'll be creating a simple function which is going to be called as Floyd Warshall. Okay, so let's just create a function calling it the Floyd Warshall. So inside of it, we'll have a single argument which is going to be our graph. Then we'll have the number of vertices in the graph which will be denoted by an V. Simple as that. We're not going to overcomplicate the thing that by writing vertices or anything like that. We just simply define it by V. Then the length of the graph is going to be the value of V, which is going to be the number of vertices. And then we initialize the distance matrix, which is going to be initialized like this. Dist is equal to float inf and then multiply by V for underscore in range V. So that's how it works. Now we'll just set the distance according to the given graph. So for that, we'll use two loops for I in range V and for j in range V. Okay, so let's make it capital. So what I says, we'll just keep it capital for no fucking reason. We're just keeping it capital. All right. So now setting the distance. Dist I of j is equal to graph of ij. That's it. Now we're talking. Now set the distance from each node to itself as 0. That's what our next step is going to be, right? As we've studied the pseudocode. So for I in range V, and this is how we're done. Now update the distance matrix. That's what we're going to do. So we'll need 3 loops. First, I'll keep it K, I, and J. These are going to be our 3 basic loops that we're going to use. So we'll use the minimum min inside of it. Dist ij, and then minimum of dist ij, comma dist ik, and plus dist kj. Then return the dist. That's what we're going to do. Now, example graph represented as 2D adjacency matrix. That's what we're going to be doing, right? So it is going to be a simple 2D adjacency matrix. You can just simply go on to any if you have any, I haven't been to any like adjacency matrix visualizer or anything like that. But if you go on to internet and try to find it, you will most likely find it. And if you put on this exact graph data, then you will be able to see how does this graph actually looks, right? So I'm just making it up in my mind that how this graph actually looks, and it looks kind of pathetic in every regards. All right, so this is going to be our float INF. The last will be float INF, then again float INF, and 2O. That's what I think it shall be. Okay, right. So now we are good to go. Now print everything. And for that we'll be using our distances is equal to Floyd Warshall, not Warshall, graph. So we'll be doing a loop up here for row in distances and then print the row. That's what we're going to do. So it'll just simply it will print all the pair which have the shortest distance or shortest path. All right, so 27 dot pi, and I think it's here we're lacking an n. All right, done. Let's run this and we have an error, and I think okay, that's comma error. All right, run it again, and I guess we'll have another error anyways. So we have one more error, and here it is, the multiplied one, and I think it's boom, done. Okay, so now we can see the shortest path is up here. So this is the shortest path that you can travel with. So that was a wrap up on the Floyd Warshall algorithm. It's a fantastic problem solving, or let's just say it's a fantastic for solving all pairs shortest path problem efficiently. So if you found this video helpful, make sure to like and subscribe. If you didn't find it helpful, make sure to unlike. All right, so if you find it helpful, make sure to subscribe Code with Akya and hit the notification bell for more algorithms and coding tips. Next, we'll dive into the Prim's algorithm to find the minimum spanning trees. So thanks for watching. See you in the next one.